Okay, in this lesson we're going to look at starting to compare graphs. Your essential question today is, how do the slope and y-intercept change a graph? And when you answer that, I want you to be really specific. Don't just say that it affects this and affects that. Go into detail about how you know and how one number will do this and one number will do that. I think it'll make more sense after we talk about it. Okay, so the first thing that I wanted us to know is I wanted us to know about the linear parent function. So we've been talking about linear functions. And the linear parent function is simply f of x equals x, that would be in function notation, or y equals x. That's a linear equation. The reason it's the parent function is because it's the most basic of all the linear functions. Okay? And so let's just talk, so if we have to graph this, we know. So what is the slope on our linear parent function? The slope would be 1. Remember, this is an understood 1. So the slope is 1. The y-intercept, there's nothing added or subtracted on, so the y-intercept would be 0. Okay? Now, we know that slope tells us the steepness of a line. Okay? And we should realize that the greater the absolute value of the slope, so basically the greater the number, and if it's negative, then we're still thinking about its absolute value, then the steeper the line is. Okay, so that's one thing that slope is going to tell us. So we can look at the number and compare the numbers, and whichever has the greater absolute value would tell us which line was steeper. A sign change, so if we change our slope from positive to negative, changes the direction of the graph. So if we have a positive slope and then a negative slope, then our lines are going to crisscross, right? Or if I go from a negative slope to a positive slope, they're still going to crisscross and intersect. Changing the y-intercept. Let's talk about that. So if we change the y-intercept, we know the y-intercept is on the y-axis, right? So changing the y-intercept moves the graph up or down. It just slides it up or down. Changing just the y-intercept does not change the slope. Okay, so we're just adding or subtracting something that doesn't change the slope. But it does change the x-intercept. Okay, so these are all important things to realize. So let me give you an example. If I had a graph like this, and then all of a sudden my new graph looked like this, all I did was change my y-intercept, but it also changed my x-intercepts. Because we're sliding it, we're moving it around. Okay, so what I want us to do is we're going to look at some equations, and we're going to identify how did the slope change, how did the y-intercept change, how is the x-intercept changing or affected, or did it change? We're not going to be super specific on some of these things, but we can at least recognize if it changed. And we should be able to tell just by looking at the equations. Now I'm going to suggest that it's really important that we know what our slope is and we know what our y-intercept is every single time. Okay? So in this first equation, f of x equals x, that's our parent function. The slope is 1. The y-intercept is 0, right? But in function g, our slope is 3, and our y-intercept is -2. Okay, so let's talk about what's happening. So what we're basically doing is we are describing our new function which is function g. Okay? So function g, how does the slope compare? Okay, notice it's 3 now. 3 is greater than 1. So that means this new graph is going to be steeper. That's the first thing that's going to happen. And let's look at the y-intercept. The y-intercept went from 0 to -2, right? So our graph moved down, and we could actually say it moved down 2, right? And that means that's specifically our y-intercept. Our y-intercept moved down 2. And we know if we're sliding this down and we're changing the steepness that our x-intercept changes. And that's all we're going to say for now about the x-intercept. Okay, let's look at the next one. Again, we want to know what our slope is, and we want to know what our y-intercept is. Our slope is 2 in function f. Our y-intercept is 3. And I forgot that I've named these functions different things. So basically we're describing what it's changing to. And then in function h, our slope is -2. The y-intercept is 3. Okay, so let's look at our slopes. The only thing that changed here was our sign, right? We didn't change, the absolute value of both of these is still 2. So the steepness is not changing, but we changed signs. So that means that the slope changed direction. Okay? And then the y-intercept, notice it's the same. The y-intercept is exactly the same. So the y-intercept is the same. Now let's think about this. If we have a graph, and we could absolutely type this into Desmos and look at the graphs, or we could graph it on graph paper. So let's see, our first graph would look something like this. This would be function f. And then our second one would go the other direction, right? Function h. So what happened to the x-intercept? Did the x-intercept change? Absolutely. Okay, so all we were going to say is that the x-intercept changed. Okay, let's look at the next one. In number 3, our slope is 1/4. The y-intercept is 0. In function r, my slope is 3. My y-intercept is -4. Okay, so let's talk about our slopes. We went from 1/4 to 3. So this new graph is going to be steeper because 3 is greater than 1/4. Okay, my y-intercept means that the graph moved which direction? The y-intercept moved down 4. And if we're moving the y-intercept down, then that means the x-intercept changed as well. And we changed the steepness. If we change the slope or we change the y-intercept, then it's going to affect the x-intercept. Okay, 2 more. If our slope is 5, our y-intercept is -6. In function g, our slope is 1/2. Our y-intercept is 2. Okay, so I want you to just pause for a second, pause the video, and see if you can tell me what happens to the slope, what happens to the y-intercept, what happens to the x-intercept. And then restart the video. Okay, so this time our slope went from 5 to 1/2. So it got smaller. So our new graph is actually less steep. It's flatter, right? Okay, now let's talk about our y-intercept. It went from -6 to 2. Let's visualize this on the graph. 1, 2, 3, 4, 5, 6. We went from -6 up to 2. So it did move up, right? So the y-intercept moved up. How many is that? That's 6, 7, 8. It actually moved up 8, right? And then because both of these actually ended up changing, we're going to say that the x-intercept changed. So you should kind of be seeing a pattern about that x-intercept on these types of problems. That won't always be the case as we look at different types of transformations. Okay, so let's look at the last one. Again, I want you to pause the video and I want you to identify your slope and y-intercepts and then see if you can describe what happens to each attribute. Okay, so our slope is -4. The y-intercept is 3. Our new slope is 2. The y-intercept is -5. Okay, so let's think about this. So first of all, let's talk about their absolute value. It would be 4 and 2, right? So the new graph has a smaller slope, so it's less steep. Okay, and we went from a negative slope to a positive slope. So it's less steep and it changes direction. So we're going to have crisscross lines if we were to graph this. It changes direction. The y-intercept, we went from 3 to -5. So the y-intercept went down how many? And you could actually just do some subtraction. 3 minus -5. It went down 8 units. And then hopefully you're seeing that pattern and that the x-intercept changed. And that's all we'll be saying about that. Okay?